Suppose you need to organize an Easter egg hunt for 3 kids. You've got the eggs, but you don't have their baskets yet. So what would you rather choose? 3 baskets that are completely different sizes, or 3 baskets that are the same size? It makes more sense to use baskets that are the same size, partly because the kids won't be mad, and partly because it will make it a whole lot easier to tell who got more eggs. After all, if the baskets are the same size, then all we're really comparing are the number of eggs inside the basket. That's the idea behind grouped frequency distributions. When we have data, we need to figure out a way to organize it so that we can tell something about the characteristics of the data. In this case, the data points are represented by the yellow dots, and if we look at the number line, we can tell what values each of those dots had. In a grouped frequency distribution, we want to organize the data so that we have equal-sized baskets or equal-sized groups. It doesn't matter how many groups we choose, but we want to make sure that the size of the groups are the same. Just like the Easter baskets didn't have to contain the same number of eggs, in a grouped frequency distribution, each of the groups don't have to contain the same number of data values. They just have to be the same sized containers for the group. So let's see how to organize data into a grouped frequency distribution. We'll use the data in this picture as our example. So let's suppose we still want to organize this data into 5 classes. That means 5 groups. The first thing we'll look at is the distance between the smallest and the largest data values. That's called the range, and in this case the range is 18 minus 1 or 17. Now we need to take that distance and divide it equally into 5 pieces because we want 5 classes. So if we take that 17 and divide it by 5, we'll get the width of each of the classes. In this case, 3.4. So what do we use for the width? Well, no matter what you get when you take the range and divide it by the number of classes, you're always going to use the whole number that is bigger than the number that you got when you divided. In this case, that would be 4. Let's use a table to show our grouped frequency distribution. The first class has to start with 1, and it has to also accommodate 4 total possible data values. In this case, that would be 1, 2, 3, and 4. The next class would have to start right after 4, which is 5, and also accommodate 4 possible data values, which would be 5, 6, 7, and 8. The next class would have to start right after 8, which would be 9, and accommodate 4 data values, which is 9, 10, 11, and 12. The next class starts right after 12, that's 13, and it has to accommodate 4 possible data values, so that's 13, 14, 15, and 16. And then the last class has to start right after 16, which is 17, and accommodate 4 possible data values, which is 17, 18, 19, and 20. So now you can see what our classes are. To get the frequencies, we just have to count how many data values are within each class. So the first class has 6 total data values. We're just counting the dots. Second class also has 6 data values. The class from 9 to 12 has 3 data values. The class from 13 to 16 has 2 data values. And the class from 17 to 20 also has 2 data values. Showing the data values and the classes like this on a number line can make it a lot easier to understand what's going on with group frequency distributions. But when you're dealing with data, you probably don't have the data represented that way. You probably just have a list of data values. So let's use this list of data values and make a grouped frequency distribution for it. We're going to divide the data into 4 classes. So our grouped frequency distribution will look like this. We'll start by finding the smallest and largest data values that we see. In this case, the smallest is the 4 and the largest is the 36. We use the smallest and the largest values to find the range of the data, which in this case is 36 minus 4, or 32. That's the distance from the smallest to the largest data value. If we want 4 classes, we need to divide that into 4 equal pieces. So we'll take that 32 and divide it by 4, and we get 8. Now here's the tricky thing. No matter what you get when you divide the range by the number of classes, you have to take that number and increase it to the next largest whole number, which means we need to use 9 as the width of each class. The reason we need to do that is if we don't, we will not be able to find a place in the last class for our largest data value. Now let's label the classes in the table. The first class has to start with 4, and the width of each class is 9. Then the next class would start at 4 plus 9, or 13. So the next class would start with 13 plus 9, which is 22, and then the last class starts at 22 plus 9, which is 31. Now we need to find the ends of each class. For the first class, look at where the second class started and work backwards. So if the second class started at 13, the class before that had to end right before the 13, which would be 12. Now to get the ends of the rest of the classes, I can still use the width and keep adding that on to the ends of the previous classes. So for example, for the second class that starts with 13, I'm going to look up to the first class, which ended at 12. 12 plus 9 is 21, so that's where the second class ends. 21 plus 9 is 30, so that's where the next class ends. And 30 plus 9 is 39, so that's where the last class ends. Now we've done all the hard work. Now the easy part. We just need to do some counting. So for the first class, which is from 4 to 12 inclusive, we'll find all the numbers that fall within that range. And we can see that there are 4 numbers that fall in that first class. The next class is everything from 13 to 21 inclusive. And there are 6 numbers that fall into that range of values. Third class, we're looking for everything from 22 to 30 inclusive. There's 5 numbers there. And then the last class, everything from 31 to 39 inclusive, and there's 2 numbers there.